Hi everybody. In this video, we are going to talk about proofs with angles. Just like in the previous video that you watched, hopefully, we talked about segments and the proofs that can go with pictures with segments. Very similarly, we're going to talk about proofs, but we are going to use angles. So in this given example, we have a picture with 3 different angles going on. And it's telling us in the given that angle PQR is a right angle. Just like in the last video, I'm going to highly recommend that anytime you see a vocabulary word in your given, you know you're probably going to use its definition. And the vocabulary word that we see here is right angle. So we're probably going to have to use the definition of a right angle. What does it mean to be a right angle? If you said that a right angle measures 90 degrees, you're right. And the way that we label that in the picture is with this little box. Okay, so I'm going to label my picture. And the very first statement, angle PQR is a right angle, that was given. Second statement says the measure of angle PQR equals 90 degrees. Oh yeah, because it's a right angle. So this is where we're using that definition of a right angle. I'm going to use the symbol for angle. Okay, next step says the angle PQS plus the measure of angle SQR equals the measure of PQR. Whew, that's a lot of letters. Let's take it one piece at a time and just find those angles in the picture. Angle PQS. PQS, it's here. Remember, to find the angle, you follow the letters in order. So PQS is this angle right here. Then angle SQR. So you find S, you find Q, you find R. That's this angle here. It says that that equals the measure of angle PQR. That's the whole thing. Oh, remember segment addition was small segment plus small segment equals big segment? Well, we learned something else with addition. We learned angle addition. Angle addition was when you have small angle plus small angle together makes a bigger angle. That's exactly what's going on here. They're saying that this small angle put together with this other small angle together gives us the big angle. So we call that angle addition. Okay, the next step, oh, it looks very similar, right? The only thing that's different is this piece. Oh, but we know the angle PQR is a right angle. They told us that in step 2. So I'm going to call that substitution. We're going to substitute what we know about angle PQR with its measurement 90. And then the very last one, we're trying to prove that angle PQS, angle SQR are complementary. Remember that word complementary? What does complementary mean? Complementary means that they summed 90. That's exactly what they do. They sum to 90. We just proved that in angle 4. And complementary, that's a vocabulary word. So hopefully that kind of gives away what the reason is. It's the definition of complementary. All right, let's try another one. All right, we have a picture. They give us some information about angle 2 and 3. They're congruent. They tell us some information about angle 1 and 2 forming a linear pair. And we need to prove that angle 1 and angle 3 are supplementary. So I'm going to go ahead and mark some of this stuff in the picture. Angle 2 and angle 3 are congruent. Here they are. That's given. Oh, there it is. Only angle 2 and angle 3 is labeled there in the given. So let's find this other given and label that as given too. There it is. And linear pair, that's a vocabulary word. Probably going to have to use its definition at some point. Let's see here. Step 2 says the measure of angle 2 equals the measure of angle 3. Oh, okay. So we went from, in step 1, angle 2 being congruent to angle 3 to their measures being equal. You remember what it's called when we go from pieces being congruent to their measures being equal? Yeah, that's the definition of congruence again. Ooh, that pops up a lot. All right, and now we know that angle 1 and angle 2 form a linear pair. What does it mean to be a linear pair? There's 2 requirements. Yes, so for a linear pair, you have to have 2 angles that form a line. And when they form a line, they're supplementary. So to be a linear pair, the definition says that you have two adjacent angles and they are supplementary. That's your definition of linear pair. So when step 4 says angle 1 and angle 2 are supplementary, well, yeah, of course they're supplementary because they're a linear pair. So we'll say that's the definition of a linear pair. You could also write like that you could write it out. All linear pairs are supplementary. That would be okay. Like if you didn't want to write the whole thing of definition of linear pair, you could just write out linear pairs are supplementary. That's a good reason. All right, number 5, angle 1 and angle 2, angle 1 plus angle 2 equals 180. Well, what's supplementary mean? Supplementary means they add to 180. So now that we know that they're supplementary, we know they add to 180. That's the definition of supplementary. Knowing that they're supplementary tells me that they add to 180. Okay, now step 6 says the measure angle 1 plus the measure angle 3 equals 180. Remember way back here in step 1 and 2, we said the angle 2 and angle 3 were congruent. So I can take what angle 2 equals and replace it. And when I take what something equals and replace it in the equation, we call that substitution. All right, and now we know that angle 1 and angle 3 are supplementary. Okay, well, angle 1 plus angle 3 equaled 180 right here in step 6. And if they add up to 180, we call that supplementary. So this is the definition of supplementary again. You can use the same reason as many times as you need to in a proof. All right, number 4. I would like your number 3. I would like you to go ahead and try this one. It's not that long. Go step by step, label your picture. Try this one, and we'll go over it in a moment. Do that now. All right, so check your answers. I want to talk about reason 5. This is kind of a new theorem to our class, and so I want to talk about it and what it means. But first, we have the givens. There they are. Steps, reason 1 and 3. A right angle, if two angles form a right angle, that means they add up to 90, which means they are complementary. So it's the definition of complementary. You could have also put definition of right angle. That probably would have been okay. Angle 1 and angle 3 are complementary here in step 4. Again, that's the definition of complementary, since when you add them together, you get 90. Let's talk about reason 5. Okay, there's 2 theorems that are going to pop up that are very similar. We've got the congruent complements theorem. And the congruent complements theorem says if you have two angles that are complementary to the same angle, then those 2 angles are congruent. Okay, and I'll show you a little example here. Okay, so let's pretend I have angle A and angle B, and they add up to 90. And then I have angle A and angle C, and they add up to 90. According to this congruent complements theorem, angle B has to equal angle C, right? Because angle A is the same here and 90 is the same here. So these have to be the same. So angle A is complementary to B, angle A is complementary to C. So B and C are both complements to angle A. And so if angle B and angle C are both complements to angle A, that means that angle B and C are congruent. Okay. So again, the congruent complements theorem says that if you have 2 angles that are complements to the same angle, then those 2 angles are congruent. So for my example, angle A and angle B are complements because they add to 90, and angle A and angle C are complements because they add to 90. So angle B has to be the same as angle C. So for this example, right, we had angle 1 and angle 2 are complementary. And we have angle 1 and angle 3 complementary. And so because angle 2 is complementary to 1 and 3 is complementary to 1, that means that angle 2 and angle 3 have to be congruent. And the name of that theorem is the congruent complements theorem. All right. Oh, there's a new vocabulary word in this one. In this one, I see the word bisects. We've learned that vocabulary word before. Remember, bisect means cut in half. We'll do this one together. The given says that ray BE bisects angle ABD. So I'm going to go ahead and put that in the picture. BE is here, and it's bisecting angle ABD. Bisect, of course, means cut in half. So if BE is cutting this angle in half, that means each of these parts have to be equal. And then it also says that BD is bisecting angle EBC. So if BD is bisecting this angle, that means that these pieces have to be congruent. Okay, so step 1, BE bisects angle ABD, that's given. I'm gonna find the other one too. BD bisects EBC, here it is. All right, so if ray BE is bisecting angle ABD, we marked these two congruent because that's what a bisector does. It cuts the angle into two equal parts. So step 2 is literally saying this angle ABE is equal to this angle EBD. So this is the definition of a bisector. You can write definition of bisects, definition of angle bisector. And then step 4, we know that BD is bisecting this angle, which means these pieces have to be equal, which is what it's saying. Angle EBD and angle DBC are equal. So this is our definition of a bisector again. So then why would angle ABE be congruent to angle DBC? Okay, well, I'm going to look right here at step 2 and step 4. Look, angle EBD is a common, right? Angle ABE is congruent to EBD, and EBD is congruent to DBC. So therefore, angle ABE has to be equal to DBC. This is very much like our law of syllogism, but we don't use that for equations. For equations, we call it the transitive property. And there it is. Okay. In number 5, they're telling us that angle RSU is congruent to angle VST. And we're going to prove that angle RSV is congruent to angle UST. So let's start by putting that given in the picture. Angle RSU, here it is congruent to angle VST. There it is. Okay, so that's given. Then it says the measure of angle RSU is equal to the measure of angle VST. So it looks just like step 1. It's just instead of parts being congruent, their measures being equal. So this is our definition of congruence. All right, now we've got some addition going on. We're working with angles. So my brain right away goes to angle addition. You should always see, is this angle addition? Okay, and it's always good to double check, but it says angle RSU, okay, that's this angle right here, plus angle USV, that's this angle, equals the measure of angle RSV. That's exactly angle addition. So just one more time. You've got angle RSU, that's here, plus angle USV, that's this guy, equals angle RSV, this whole thing. There you go. Small angle plus small angle equals big angle. This is angle addition. Okay, now let's look at step 4. I suspect angle addition again, but I'm going to double check just in case. It says angle VST, that's this angle, plus angle USV, that's this angle, equals angle UST, that's this angle. Oh, there we go. That's angle addition again. Two angles added together to get a larger angle. Okay, now step 5 says angle RSU plus angle USV equals UST. That's not angle addition because RSU is over here. And RSU plus UST equals plus USV equals UST. That's not angle addition. Okay, just to show you why it's not. We'll use blue. So angle RSU is here. Whoa, okay, there we go. And angle USV is here. When you add those together, I do not get this big angle. Okay, I would have gotten angle RSV. So there's something else going on here, not angle addition. But look here, UST is the same, USV is the same. The only thing that's different are these guys. Oh, but we learned right up here in step 2 that angle RSU is equal to VST. So I can take what angle VST equals and replace it in the equation. Substitution. All right, nice. Now, let me get rid of all this blue. Now it says angle RSV is equal to UST. Well, see, here's RSU plus USV. RSU plus USV, these are the same, which means these are the same. So that's, you can say transitive property, you could say substitution, both would be correct. All right, and then once we know that the measures are equal, we know that the angles are congruent. That's your definition of congruence again. All right, ooh, this is fun. We have angle 1 and angle 2 are complementary. Angle 3 and angle 4 are complementary. We're going to prove that angle 1 is congruent to angle 4. Okay, so let's put all those givens in there. Angle 1 and angle 2 are complementary. Given. Angle 3 and angle 4 are complementary. Given. Here's our vocabulary word, complementary. What does complementary mean? It means they add up to 90. That's exactly what we're seeing here in step 3 and 4. Angle 1 and 2 are complementary, which means they add to 90. So this is the definition of complementary. We know that angle 3 and angle 4 are complementary, which means they add up to 90. So again, this is the definition of complementary. Now, angle 2 congruent to angle 3. All right, here's another trick or tip for writing proofs. I would write this or add this to the list that you have. When you have lines crossing each other, immediately you should start thinking about vertical angles. We learned about vertical angles in Unit 1. Vertical angles occur when you have two lines that intersect each other, and those are the angles that are across from each other. And we know that vertical angles are always congruent, always. So as soon as I saw these two lines crossing each other, my brain immediately said, oh, those are congruent. So in step 5, where it says angle 2 is congruent to angle 3, I know that because vertical angles are congruent. You can call that the vertical angles theorem. You can call that the definition of vertical angles, whatever. Vertical angles. You can even write vertical angles are congruent. Okay. So if I know that the angles are congruent, I know that their measures are the same. So definition of congruent again. Okay. Now let's look at step 7. And we'll do green. We know that angle 2 equals angle 3. We just said that there in step 5 and step 6. And we have a measure of angle 1 on this side and a measure of angle 4 on this side. What do you think? Did you say substitution? Maybe you did, maybe you didn't. But I mentioned that angle 2 and angle 3 were congruent, but also remember, look, here's angle 1 plus angle 2, and here's angle 3 and angle 4. Angle 1 plus angle 2 is 90. Angle 3 plus angle 4 is 90. They're both equal to 90, which means these guys have to be equal. So that substitution, did you say transitive? That would be okay too. If I could spell right, that'd be great. So substitution or transitive. All right, so now angle 1 plus angle 2 equals angle 3 plus angle 4. Angle 1 plus angle 3, where'd that come from? Remember, angle 2 equals angle 3. So I can take what angle 2 equals and replace it. So step 8 looks just like step 7, except I replaced the angle 2 with what it equals, angle 3. So there's your substitution again. All right, well look, you have an angle 3 on both sides. See it? Angle 3 and angle 3 on both sides. What happens if I were to go ahead and subtract angle 3 from both sides? So subtract angle 3, subtract an angle 3. Well, these guys would cancel, and these guys would cancel, and you're left with angle 1 and angle 4. So if you subtract the same thing from both sides, yes, that is the subtraction property. And if we know that the measures are the same, then of course those angles are congruent, and that's the definition of congruence again. Whew, that was a lot. But if you take it step by step, it's really not that big of a deal. And really, if you follow all these little tips and tricks I'm giving you, using definitions of vocabulary words you know, using that definition of congruence, putting in your givens, it really takes away a lot of the other steps and can make the ones that maybe are a little trickier a little bit easier because you can focus on them a little more. All right. Oh, we did this one back in segments. We're going to skip this one. These are all the segments. How did they get here? That's silly. All right, that was the last proof of the lesson. All right, proofs can be tricky, especially because it's not something that you've really done before. Yes, you've shown your work. Yes, you've justified your steps, but you've never done it really in this formal proof way before. And now we're adding the geometric shapes. So the really only good way of getting good at this is to practice it, right? If you watched me do proof after proof after proof and you never did it once yourself, I don't know if maybe you'd be good at it or not, right? You don't really get good at something by just watching someone else do it. If that was the case, I would be a professional football player, right? But I'm not. Clearly, I'm not. So the best way to get good at this is to practice it. There are practice problems on OMHS, and if you want more practice problems, hit me up. Send me an email. Ms. Grandy, can I have some more practice problems? And I'm happy to send them to you and happy to help you out. Have a great day, everyone.